So we had discussed one relation, rather two relations, one of which was delta H is equal to delta U plus P delta V. And the second relation was delta H is equal to delta U plus delta NGRT, where delta Ng is number of moles of products minus number of moles of reactants only for the gaseous system. Only for the gaseous system. Mane only for gaseous reactants and products. So this is what we have learned till the last class. Now to further continue with, let us try out a question so that we can understand. Calculate delta H minus delta U. Calculate delta H minus delta U. Excuse me. For the following reactions. For the following reactions. Number one, combustion of glucose, which is in solid state. Now, glucose is a hydrocarbon, and remember always that whenever any hydrocarbon is combusted means burning with excess of oxygen. So in that case, we can write C6H12O6 solid plus oxygen gas gives CO2 gas plus H2O liquid. And you need to balance this up. So obviously, when you balance it up, carbon is 6, so we put 6 here. Hydrogen is 12, so we put 6 H2O, and oxygen are 2, 6 are 12, plus 6, 18. Out of 18, 6 has already been placed here, so it will be 6. Tell me what is the delta Ng for this reaction?
So 0.
Is it 0? So what is the number of moles of gaseous product? 6. Okay. And what is the number of moles of gaseous reactant? That is also 6. So 6 minus 6 will be 0. So therefore, delta H is equal to delta U plus 0 RT, or delta H minus delta U will be equal to 0. So the difference between delta H and delta U for combustion of glucose comes out to be how much? It is 0. Clear?
Yes.
I hope it is understood how to calculate the enthalpy of combustion.
Sir,
Yes?
can you pin your video, please?
Okay. Okay?
Yes, sir.
I hope it is clear to everyone. Can I proceed? Done or not?
Yes, sir.
Okay. So just now, whatever question I have given was a question on enthalpy of combustion. So we have already discussed that enthalpy is something which can be defined as the heat change accompanying any reaction at constant pressure. So at constant pressure, okay, so whatever heat change is going on is referred to as enthalpy change. So there are various types of enthalpies, and whenever we write any reaction, and after writing down the reaction, suppose we have carbon solid plus oxygen gas giving carbon dioxide gas. So we write delta H equal to minus 393.5 kilojoules per mole. So this type of chemical reaction, where a reaction followed by delta H value is written, are called thermochemical equations. So far in chapter 1, we did not have delta H value. We had only the chemical reaction, which was balanced chemical reaction. But along with the balanced chemical reaction, when you also write the delta H value, so that becomes a thermochemical equation. So delta H that we write is called the enthalpy change. The enthalpy change of this particular reaction is minus 393.5. So there are two types of thermochemical equations. There are two types of thermochemical equations, one of which is called an endothermic reaction. Endothermic reaction. So how do I know, or how do I define an endothermic reaction? Those reactions which are accompanying the absorption of heat, absorption of energy, is called endothermic. And for endothermic, we write delta H equal to positive. And if the second type of reaction called exothermic reaction is being carried out, so delta H will be negative. So with the help of this particular chemical equation, we can get information regarding the thermochemistry of the reaction. By looking at the equation, what we can say? We can say that when 1 mole of carbon is combusted, 393.5 kilojoules of energy is released. And how do I know that it is released and not absorbed? By looking at the sign convention, we can make out. Likewise, if instead of minus 393.5, had it been plus 393.5 given, then I would have said that during the combustion of 1 mole of carbon, 393.5 kilojoules of energy is absorbed. So by looking at the sign convention, we can make out whether during the process, whether energy is released or whether energy is absorbed. So thermochemical equations gives us information along with the balanced chemical equation about whether how much of energy is released during the process or how much of energy is absorbed during the process. So this sign convention is very important. So we are going to talk about thermochemical equations. So write down the next topic as thermochemical equations. What are thermochemical equations? A balanced chemical equation in which the enthalpy of reaction delta RH is also mentioned delta RH is also mentioned is called a thermochemical equation. Now this delta RH stands for enthalpy of reaction. Reaction can be of various types. It can be a combustion reaction. It can be a formation reaction. So it can be of various types. So it's a generalized expression. In such equations, physical states of the substances are also mentioned. Now, this is very important for us to remember that whether the reacting species and the product which are formed are solid, liquids, or gases, that must be mentioned within bracket. Why? Because if you don't mention it, then we will be confused that whose number of moles should be taken and whose should not be. So therefore, it becomes important to mention the physical states of the substances. So say, for example, we have C2H5OH, ethanol is reacting with oxygen and being a hydrocarbon, so as usual, it will be producing carbon dioxide and water, but with a different balanced equation. So it is twice CO2, thrice H2O. Oxygen is 3 plus 4, 7, out of which 1 has gone there. So if you write only this much, it will not be thermochemical equation because delta H is missing out. So if I write delta RH equal to minus 1367 kilojoules per mole, then the thermochemical reaction is complete. One more important thing. If sometimes you get a degree sign given along with the delta RH, so you have to remember that when degree is given, so the same enthalpy of reaction will be called standard enthalpy of reaction. So delta H is called standard enthalpy of reaction. So what is the significance of this extra term, standard enthalpy of reaction? And if degree is not placed, then it will be simply called enthalpy of reaction. So standard means something which is known to us. So when we use the term standard, it means that the temperature under consideration is 298 Kelvin and the pressure that is applied during the reaction is 1 bar. But if any one of the two are not maintained or both of them are not maintained, we don't put degree sign over the delta RH. So it becomes simply enthalpy of reaction. But when we put a degree over it, so it becomes standard enthalpy of reaction. Is it understood up to this much?
Yes, sir.
Okay. Please write down up to this much so that we can further proceed. हो गया? Can I proceed?
Yes, sir.
Oh. So reaction can be anything. So for general term, we are using the standard enthalpy of reaction. But when it is specified that what type of reaction is going on, so you will see that the same standard enthalpy of reaction can be called as, suppose we have delta RH degree. Okay, so which is a standard enthalpy of reaction. So you will come across various different types of enthalpies. When we write delta CH degree, so what is the significance of this C? So remember, C stands for combustion, and this will be standard enthalpy of combustion. Standard enthalpy of combustion. If that specific reaction given to you is a combustion reaction, then standard enthalpy of reaction will be also called as standard enthalpy of combustion. If the standard enthalpy of reaction is written in this manner, where you see that I have written now F. So F stands for formation, when 1 mole of anything is formed. So always remember that whenever I'm using the term enthalpy change, we always talk about 1 mole of any substance, whether it is combusted or whether it is formed. So delta FH degree will be called standard enthalpy of formation. Standard enthalpy of formation. Similarly, if I write delta FUS H degree, so FUS is the short form for fusion. Fusion involves conversion of a solid to a liquid without changing the chemical formula. It will be called standard enthalpy of fusion. Similarly, if it is written as delta VAP H degree, so VAP is the short form for vaporization. So the same thing will be called standard enthalpy of vaporization. Standard enthalpy of vaporization. When we write as delta sub H degree, so sub is the short form for sublimation. So it will be called standard enthalpy of sublimation. Sublimation involves conversion of a solid to its gaseous form directly. Vaporization involves conversion of liquid to vapor. And fusion, as I told you, is the conversion involving solid to liquid. Apart from that, you will also come across various other enthalpies. Delta AH degree, which is called standard enthalpy of atomization. Standard enthalpy of atomization. So there are various types of enthalpies depending upon what kind of reaction we are dealing with. We will have delta HYD H degree. It is called standard enthalpy of hydration. Standard enthalpy of hydration. What do you mean by the term hydration? Whenever a salt is dissolved in water, so from the water, it will pick out some waters of crystallization to form hydrated salt. And during this process, whatever enthalpy change is going on, so that will be called standard enthalpy of hydration. So these are different types of enthalpy changes depending upon what reaction is being carried out. Now, so far, whatever reactions we have discussed, the examples that we have come across, they were all dealing with combustion. And therefore, those enthalpies of reactions or standard enthalpies of reaction were or can be also called standard enthalpy of combustion. But every reaction is not combustion. When I use the term combustion, so it has to be specifically reacting with oxygen. Whenever any substance reacts with oxygen, then only the process will be called as combustion. But other reactions may also be possible, and other reactions will also be associated with some heat change. So those will be accordingly called as enthalpy of formation or enthalpy of fusion or enthalpy of atomization, depending upon the type of reaction. ठीक है, हो गया?
Yes, sir.
Okay.
Yes, sir.
So now we need to understand certain sign conventions associated with the thermochemical reaction. I've already told you that if delta H is negative, so it is meant for an exothermic reaction. If delta H is positive, it is meant for an exothermic reaction. So apart from that, what other informations can we get from the thermochemical equation? Let us try to understand. So conventions about thermochemical equations. Conventions about thermochemical equations. What are the conventions? Number one, delta RH degree, if negative, then what type of reaction we are actually talking about? The reaction is exothermic, and delta RH degree, if positive, the reaction is endothermic. So this I have already told you regarding the sign conventions. So if for any reaction, if you see that for delta RH degree, the enthalpy of reaction, the standard enthalpy of reaction is given to be a negative sign. So actually what kind of reaction it is? It is exothermic. And if it is positive, it is endothermic. The coefficients of different substances Now, what is the meaning of the term coefficients? Coefficients are the numbers which are written in front of the reactants and products. And what are these numbers suggesting? In a balanced thermochemical equation, shows the number of moles of the respective substances. Shows the number of moles of the respective substances. Number 3, the unit of delta H is kilojoules per mole. and it shows the change in enthalpy per mole of the substance. So delta H is always calculated for 1 mole of any substance. So when I say enthalpy of combustion, it means that when 1 mole of any substance is combusted, then what will be the enthalpy change? When we say enthalpy of reaction, it means that when 1 mole of any substance is formed, then what will be the enthalpy change? So we always calculate the enthalpy change in terms of 1 mole. Point number 3, on reversing a reaction, delta H sign is also changed. So when you reverse a thermochemical reaction, the sign of delta H changes, but magnitude remains the same. Say for example, I told you that when carbon plus oxygen gives carbon dioxide, and during this process delta H is say minus 393.5 kilojoules per mole. If you reverse this reaction theoretically, so that carbon dioxide is written on the left hand side and carbon and oxygen are written on the right hand side, then the same delta H will be plus 393.5 kilojoules per mole. See, are the points clear to you or not? So whenever you reverse any chemical reaction, the sign convention of delta H will be reversed. Plus becomes minus, minus becomes plus, but the value does not change. Done or not? Can I proceed to the next point? Tell me after you have completed writing the points. I think I can rub the point number 1 at least, 1 and 2.
Yes, sir.
All points must be understood, because in the later stages, the applications of all these that we will be doing will be coming. Number 5, as enthalpy change is an extensive property. And what do you mean by extensive property? and depends upon the amount of substance delta RH degree changes with change in the amount. So it is like saying that if you are going to a market to buy 1 kg of any commodity, suppose the price of the commodity, whatever you are buying, is rupees 20. So it is implied that if you decrease the quantity, the rate will also decrease. If you increase the quantity, the rate will also increase proportionally. If you buy 2 kgs of the same substance, it will be priced at rupees 40. 3 kg, it will be 60. Likewise, if you multiply any number or divide with any number the whole equation, you have to do the same thing with the delta H value. Say carbon solid plus oxygen gas gives carbon dioxide gas. For the reaction, the standard enthalpy of reaction says minus 393.5 kilojoules. If you multiply any number, say 2, with the whole equation, then delta RH degree will also have to be multiplied with 2. And same way, when you divide the whole equation with any number, you have to do the same behavior with the delta RH value. I hope you have understood what I'm saying. Yes or no? Please answer.
Yes, sir.
Okay. So whenever you multiply the whole equation with the same number, you have to multiply the delta H value, no matter whatever be the type of reaction, with the same number, because it is extensive property, and extensive property means it depends upon the amount of substance. If you double up the amount of substance, then delta H associated with it will also be doubled up. So these are the points which must be taken care of when you are dealing with thermochemical equations. Okay, can I proceed? Written?
Yes, sir.
Okay. So after this, we now talk about enthalpy of reaction. Enthalpy of reaction, denoted by delta RH. And as I said, that if the conditions that you carry out are such that the temperature is 25 degrees Celsius or 298 Kelvin and the pressure is 1 bar, then the same enthalpy of reaction will be called standard enthalpy of reaction, and it will be symbolized as delta RH degree. Delta RH degree re ami represent ko. So hence we can write it is the enthalpy change accompanying, it is the enthalpy change accompanying a chemical reaction when the moles of reactants have reacted completely as given by the balanced chemical equation to form respective products. To form respective products. So we know that a chemical reaction involves the reaction between the reactants to form products. And during the whole reaction, heat may be absorbed or heat may be released. So how much is the change in the heat? How much is the change in the enthalpy? That change is called enthalpy of reaction. And how is it calculated? Suppose you have a chemical reaction. As for example, for a reaction, say methane is combusted, CH4 gas plus oxygen gas gives carbon dioxide gas plus water liquid. You must balance it. Don't forget to balance the equation. So it is this balanced equation. So if you are to write the expression for the enthalpy of reaction for this reaction, so we write delta RH degree is equal to sigma of delta H of products minus delta H of reactants. So sigma stands for summation. Summation means addition. So when we are to write the delta H associated with formation of each and every substance, now products have got carbon dioxide and water. So we write delta H of carbon dioxide plus 2 into delta H of water. So products are to be written first. So every molecule is associated with some enthalpy change minus delta H of CH4 plus 2 into delta H of CO2. So this is the expression. So whatever be the number of moles, that has to be multiplied accordingly. So this is the expression of writing delta RH degree for any reaction. Jiman product ase, we will be writing delta H associated with them first minus Jiman reactants ase. So this change can be negative also or can be positive also. If it is negative, then we call the reaction to be endothermic, exothermic if it is negative. And if the delta H comes out to be positive, the change comes out to be positive, it will be called as endothermic. See, it is just like saying that suppose you are running a business. And in business, we know that at first some investments are required. So if after 1 or 2 years of running the business, you want to see that whether you went profit or whether you have gained the loss during the process. So with respect to the initial investment, If the money is lesser, then it's called a loss. So exactly in the similar way, if there is a decrease in the enthalpy change, it will be exothermic. There is a loss of heat. And if there is an increase in the energy, then it will be delta H positive, and we call it as endothermic process. ठीक है, हो गया?
Yes, sir.
Okay. All of you have written. Can I proceed?
Yes, sir.
So when you come across sigma, it means it's an addition of all the reactants or all the products. The products minus reactants will give us the change in the enthalpy. So now we try to focus on the different types of enthalpies individually. So at first we talk about enthalpy of combustion, denoted as delta CH. The first type of enthalpy that we'll be discussing is enthalpy of combustion. The enthalpy change taking place when one mole of a substance is combusted in excess of oxygen is called enthalpy of combustion. The enthalpy change taking place when one mole, this one mole is very important, of a substance is combusted in excess of oxygen. So burning is also the another name for combustion. So when one mole of any substance is burnt, is combusted in excess of oxygen, during this process, whatever energy change takes place is called enthalpy of combustion. Almost all combustion reactions except for nitrogen and fluorine are exothermic. Okay, so only the combustion reactions of nitrogen and fluorine are endothermic. Rest all, whatsoever is burnt, it will be called exothermic. That means combustion always releases energy, whether it be combustion of food that we eat, whether it be combustion of the fuels that we use in our automobiles, or whether it be combustion of anything outside. Even when you are burning coal to produce carbon dioxide, during the process, energy is released. The LPG cylinders have hydrocarbons in it, and every day to cook food, we need to burn it. And the released amount of energy is actually utilized in cooking the food. All combustion reactions except for the combustion of nitrogen and fluorine are exothermic. Nitrogen and fluorine or combustion endothermic fire. When the reaction conditions are 298 Kelvin and 1 bar pressure, it is called standard enthalpy of combustion. Delta CH degree. It is called standard enthalpy of combustion. So when you are given to write down the equation for combustion, so you have to allow it to react with oxygen, that's all. So suppose carbon is combusted and you are asked to write the equation. So carbon is combusted means carbon plus oxygen gives carbon dioxide. Sulfur will give you sulfur dioxide. Any hydrocarbon will give you carbon dioxide and water. So combustion means reacting with oxygen, and you should be capable of writing the equations yourself, but don't forget to balance the equation, because whatever, you need not memorize the values. I'm simply writing delta CH degree, whatever values come out. So these will be called standard enthalpies of combustion if the reaction conditions maintained are 298 Kelvin and 1 bar pressure. So all these processes are combustion because they are reacting with excess of oxygen coming from air and they get oxidized. If it is carbon alone, it will be oxidized to carbon dioxide. If it is sulfur alone, it will be converted to or oxidized to sulfur dioxide. But here both carbon and hydrogen are there. So carbon will be oxidized to carbon dioxide and hydrogen will be oxidized to water. Okay, done?
Yes, sir.
Okay. Now, just like enthalpy of combustion, a very common term that we use, especially for fuels, with a slight difference, is called calorific value. Calorific value. So it is not enthalpy change. But whenever we talk about enthalpy of combustion, we must talk about calorific value because the food that we eat, food is also a kind of fuel, or the fuels that we burn. So they release energy and that energy is utilized in performing work. So how much of energy is released when 1 gram, I repeat, how much energy is released when 1 gram of any fuel is burnt, whereas enthalpy of combustion was calculated for 1 mole, but calorific value is calculated for 1 gram. The amount of energy released when 1 gram of any substance is burnt in excess of oxygen. is called its calorific value. So here the amount has changed. When it was 1 mole, it was called enthalpy of combustion, but when it is 1 gram, it is called calorific value. So what is the relation then between calorific value and enthalpy of combustion? But prior to that, let me tell you, this energy is generally expressed in calories. Okay, this energy is generally expressed in calories. So suppose we have a reaction carbon solid plus oxygen gas gives carbon dioxide gas, and delta CH degree is minus 393.5 kilojoules per mole. So this is not calorific value, of course. This is enthalpy of combustion. But from this equation, what we can see is when 1 mole, because this is 1 mole of carbon is combusted, 393.5 kilojoules is released. Okay, so when 1 mole of carbon is combusted, 393.5 kilojoules is released. So instead of 1 gram, we can also write, instead of 1 mole, we can also write 12 gram, because for carbon, 1 mole is equal to 12 gram. So 12 gram of carbon is combusted, 393 kilojoules is released. So 1 gram of carbon is combusted, it will give you 393.5 by 12 kilojoules is released. So this value was enthalpy of combustion, which is negative. But this value is calorific value because it is calculated for 1 gram. So hence we can say that calorific value is actually the modulus of enthalpy of combustion by its molar mass. For carbon it is 12. Every time it may not be 12. But whatever be the molar mass of that particular substance. So if enthalpy of combustion is divided by the molar mass of that respective substance which is combusted, then it will be called calorific value. Is it clear or not? Tell me if you have got any doubt. Don't try it without understanding. Okay, is it okay?
Yes, sir.
So which value is larger, enthalpy of combustion or calorific value?
So enthalpy of combustion.
Enthalpy of combustion. Why? Because 1 mole is larger than 1 gram. So if you are given enthalpy of combustion, you have to divide by molar mass. And if you are to find out calorific, you are to find out enthalpy of combustion, and calorific value is given, so you have to multiply with the molar mass. So remember this particular expression. So this was the first type of enthalpy that we discussed, enthalpy of combustion. And under enthalpy of combustion, we discussed about calorific value. The two are related in the sense that both of them are associated with combustion of anything. So thereafter, we talk about the second type of enthalpy, that is enthalpy of formation. And as the name implies, when 1 mole of any substance is formed, so write down enthalpy of formation. And the symbol for enthalpy of formation is delta FH. And if the conditions maintained are standard conditions, then of course the same enthalpy of formation will become standard enthalpy of formation, and we need to put a degree over it. The enthalpy change taking place when 1 mole of a substance is formed from its constituent elements. Okay, when 1 mole of any substance is formed from its constituent elements, it is called enthalpy of formation. If the constituent elements are in their standard states, if the constituent elements are in their standard states, it is called standard enthalpy of formation. It is called standard enthalpy of formation. Now, suppose you are to form the equation of formation of anything. So anything that is formed, suppose we are interested to form glucose. So glucose should be written on the right hand side, because anything that is formed should be placed on the right. And what you are supposed to write on the left hand side, the elements which are responsible in its formation. Who are the elements? Carbon is the element. Hydrogen must be written as H2, because in elemental form, we know that hydrogen exists as H2. Oxygen. And rest you have to balance it. Carbon 6, hydrogen 6, and oxygen 3. But don't put any number prior to the product, because the product formed should be 1 mole. You can put any number in the reactants, because the definition is not concerned with how many moles of reactants are used. The process is concerned with the substance which is formed should be 1 mole. So this is the equation of formation of glucose. So delta FH degree, whatever value exactly, if you don't recall, obviously it's not possible also to remember all the values, but whatever value will come out, that will be called the standard enthalpy of formation if the elements are in their standard state, or simply enthalpy of formation if they are not in their standard state. Likewise, if you are to write the equation of formation of methane, so methane must be written on the right hand side, and the elements responsible in the formation of methane should be on the left hand side. So this is the equation of formation of methane. So far when we were discussing combustion of something, so that something and oxygen was written, but here it is formation of something. So the substance that is formed should be on the right hand side. I hope it is clear to you. Yes or no? Tell me. Vipasha, is it clear? Jaideep?
Yes, sir.
So when
Yes,
you are
sir.
to write the equation of formation, so where should you place the substance that is forming?
On the
Right hand
right.
side.
On the right hand side. And what should you write on the left hand side? The elements which are forming the substance. And when you are to write the equation of combustion of something, so that something has to be written on the left hand side along with oxygen, and products will be depending upon what substance you are burning, and accordingly you have to complete the reaction. I'm repeating this again and again because next day we will be carrying out a very important topic called Hess law. So there you will be forming the equations yourself. Equation kita nije banabo lagibo, and depending upon whether it's a combustion reaction or formation reaction, so accordingly you have to yourself form the equations. So it's very important to make yourself clear regarding the processes. ठीक है?
Yes, sir.
Okay. So after enthalpy of formation, the next thing that we discuss are enthalpies of phase transformation. Enthalpies of phase transformation. And when we use the term phase transformation, it means that during these processes, the physical state of the matter will be changing. Now let us say that we have any substance X in the solid state, and it needs to be first converted to liquid state. And thereafter, finally, it is to be converted to gaseous state. So when 1 mole of any solid or 1 mole of any substance in its solid state is converted to its liquid state, whatever amount of energy is required will be called the enthalpy of fusion. Enthalpy of fusion. And at what temperature you are converting the solid to the liquid, it is called its melting point, because at melting point, the solid gets converted to liquid. Similarly, if 1 mole of a substance is converted to its gaseous form, during this process, whatever energy is required will be called as enthalpy of vaporization. And at what temperature this is happening? It is called its boiling point. And if directly the solid can be converted to a gaseous form, then whatever energy change is taking place is called enthalpy of sublimation. So you can see that this is a single step. These are 2 steps. But as sum total of energy is constant according to first law, so whether you take 2 steps or whether you take single step, the total energy will remain constant. So delta sub H is equal to delta fuse H plus delta vap H. So all these 3 types of enthalpies which are required for phase transformation, solid to liquid, liquid to gas, or solid to gas, are called enthalpies of phase transformation. So under enthalpies of phase transformation, we first talk about enthalpy of fusion. Delta FUSH, fusion or short form FUS. The enthalpy change taking place when one mole of a solid substance melts completely into its liquid form. One mole of a solid substance melts completely into its liquid form is called enthalpy of fusion. So suppose we have ice, and for this, in order to convert it from ice to liquid water, whatever amount of energy is required will be called its enthalpy of fusion. And if they are at standard conditions, it will be called standard enthalpy of fusion. So it is nearly 6 kilojoules per mole. Enthalpy of vaporization, which is written as delta vap H. The enthalpy change taking place when one mole of a liquid substance is converted to its vapor at its boiling point. Is called enthalpy of vaporization. So say we again take water in liquid state and it needs to be converted to water to vapor state. So during this process, whatever energy change taking place will be called enthalpy of vaporization. At standard condition, this value required is nearly 40.79 kilojoules. So both processes are endothermic because energy is required to convert solid to liquid and then liquid to vapor. Number C. Enthalpy of sublimation. Delta sub H. The enthalpy change taking place when one mole of a solid is directly converted to its vapor below its melting point. It should not melt, because if it melts, then it will be converted to liquid. Below its melting point, is called enthalpy of sublimation. So not all substances sublime. There are few solids who can be directly converted to the vapor, like iodine, ammonium chloride. These are some substances. So say we have got iodine solid getting converted to iodine gas directly. So this conversion is called enthalpy of sublimation. And for iodine, this value is calculated to be or found to be 62.4 kilojoules. As I said, you need not memorize the values, but what you should understand that why this process, whatever energy is accompanying this transformation, is called enthalpy of sublimation. So solid is directly converted to the vapors. So as I said, that enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. The sum total of enthalpy of fusion and vaporization will be equal to enthalpy of sublimation. This is a very important relation. हो गया? Can I proceed? Yes or no?
Yes, sir.
All of you have written?
Yes, sir.
Okay. So after this, write enthalpy of atomization. Delta small a h. And if degree is put, it will be standard enthalpy of atomization. Now, what exactly is atomization? So let me tell you that in order to convert any molecule to its gaseous atomic form, whatever energy is required is called the enthalpy of atomization. The enthalpy change taking place when one mole of any substance is converted to its gaseous atoms is called enthalpy of atomization. Is called enthalpy of atomization. So how to form the equation? Suppose you have methane gas. So when you apply enthalpy of atomization to methane, it will be converted to its constituent atoms in gaseous state. So carbon and 4 hydrogen all should be in the atomic form. So during the conversion of methane to atom of carbon and atoms of 4 atoms of hydrogen, because it needs to be balanced, whatever energy is required is called enthalpy of atomization. But if the atom is already present in the solid state, simply you need to convert into gaseous state. So can we say that this conversion is also enthalpy of sublimation? The second reaction, can we call this also a sublimation process or not?
Yes, sir.
Yes. So in some cases, the enthalpy of atomization may be equal to enthalpy of sublimation. Suppose we have H2 gas and you need to convert into atoms. So 2 hydrogen atoms in gaseous form, whatever energy is required is called enthalpy of atomization. So you must know by looking at the topic that what actually you are going to perform during the process. So during the atomization process, we break a molecule or break an atom to its constituent atoms all in the gaseous state. Yat product jiman form korisa eketu atomic formot hobo lagibo, and secondly they should also be in gaseous state. So that will be called as enthalpy of atomization. Okay, can I proceed to the next?
Yes, sir.
I want to complete the different types of enthalpies so that next day we can directly move on to Hess law. Next, right? Enthalpy of hydration So what happens during hydration process? See, there are certain salts like copper sulfate. It is called anhydrous copper sulfate. Okay, so when copper sulfate is put into water, so it is going to pick out 5 moles of water per mole of copper sulfate and gets converted to a new form which is blue in color. It was previously white when in anhydrous condition. And this is hydrated, which is also called blue vitriol due to its color. So during this transformation, when anhydrous salt is getting converted to hydrated salt, whatever energy change is taking place will be called enthalpy of hydration, denoted by delta HYD. So you can write the enthalpy change taking place when one mole of an anhydrous salt combines with specific number of moles of water to form hydrated salt is called enthalpy of hydration. And thereafter you can write down the equation, what exactly during the process is happening. The same way, suppose we have ferrous sulfate, FeSO4. It picks out 7 water moles to produce FeSO4.7H2. So this process is called hydration, and whatever energy is associated is called enthalpy of hydration. So we have come across the different types of enthalpies required for your syllabus. So today we have learned that whenever we talk about enthalpy change for a particular type of reaction, what exactly the changes are occurring. And accordingly, we write down the equation. So forming the equation is very important. And for that, you must know that what is a combustion process, what is formation process, what is atomization process, what is hydration process. So that is why we have discussed the different types of enthalpies in today's class. So next day, we will carry out numericals based on whatever we have discussed, along with the Hess law of constant heat of summation, from which at least one question is asked in the exam. Thank you. Good night.
Thank you, sir.
Thank you, sir.